Welcome back everyone, Houston Math Prep here, talking to you about unit tangent and principal unit normal vectors in this video. Remember that when we differentiate a vector valued function, it gives us the formula for all of the vectors that are tangent to r of t at any t value. Now this formula for a tangent vector will give us vectors of all different lengths sometimes, and it's possible we're really only interested in the direction of the tangent vector and not its magnitude, so a unit vector in this direction might be what we want to look at instead. Remember, we can always make a unit vector that points in the direction of another simply by dividing that vector by its own length or magnitude. So our formula for finding a unit tangent vector, what we'll call t hat here, remember hat signifying unit vector, is to first find the derivative of our vector valued function and then divide that derivative vector by its own magnitude. That'll give us then a formula for a unit vector that is tangent to the original vector valued function at any point, and then if we want a unit tangent vector at a specific point, we can simply plug in the value of t where we want to know. Let's work through one example with you. We want to find the formula for a unit tangent vector for our vector valued function here, 3 cosine of t, comma 3 sine of t. So if we're finding a unit tangent vector, the first thing we'll want to do is find the tangent vector formula in general, r prime of t. We'll find the derivative. We just take the derivative of each component individually. The derivative of 3 cosine t would be negative 3 sine of t. The derivative of t would just be 1, and the derivative of 3 sine of t would be 3 cosine t. We get our r prime of t, our derivative function here, as negative 3 sine t, comma 1, comma 3 cosine t. And if we want a unit tangent vector, we'll need to divide this by its own length, its own magnitude, to make a unit vector. So we'll need to first then figure out what is that length. So what is the magnitude of this r prime of t? Well, that's going to be the square root of all of these components squared, right? So negative 3 sine of t squared plus 1 squared plus this 3 cosine of t squared also. Now if we work this out, the squares underneath here, we'll get 9 sine squared t plus 1 plus here we get 9 cosine squared t. We'll need to add all those up under our root. Now you might notice here that cosine squared of t plus sine squared of t is actually, it's a Pythagorean identity. That's going to help us simplify a bit. So what we'll do is, let's go ahead and factor out our common 9 and think of this as 9 times sine squared t plus cosine squared t. Plus 1, of course. And the reason this is nice, now this is really 9 times this identity, sine squared t plus cosine squared t, that's 1. So this is 9 times 1. So we really get the square root of 10 for the magnitude of r prime of t here. So now our t hat, our unit tangent vector, remember that's going to be our derivative, r prime, divided by its magnitude. So then in this case, that will be our negative 3 sine of t, comma 1, comma 3 cosine of t. All of that divided by the square root of 10. And if we want to write it all as a vector, we might say t hat then will be negative 3 over root 10 sine of t, comma our 1 divided by root 10, and you can rationalize these, of course, if you want to. And then we have 3 over root 10 cosine of t. Moving on to principal unit normal vectors, let's say we have a vector valued function, some curve in space here in my picture, and at some t value, I've drawn here a tangent vector. So when we talk about a normal vector, we're saying it's a vector that points perpendicular or orthogonal to the curve at that point. So to start, we want to remember how many vectors there are that are orthogonal to this tangent vector that we've drawn here. And if you remember from our video about normal vectors, there are an infinite number of vectors orthogonal to this one, and they all lie in the same plane, pointing every direction that lies in that plane. But there's one in particular that we're very interested in much of the time, this principal unit normal vector. To visualize what's happening here, now that we're talking about two different vectors, let's first look at our unit tangent vector. As we travel the curve defined by our vector-valued function, the unit tangent vector points in the direction of travel or tells the instantaneous direction of change at any point. So this principal unit normal vector tells us in which direction the tangent vector is changing at any point on the curve. You can think of it as letting us know which way we're about to be turning if we were riding this curve like a roller coaster. Our principal unit normal vector is often written as n hat, and we have a formula for it here. It's t hat prime, which is the change in the unit tangent vector, divided, of course, by its own magnitude so that it's a unit vector. Let's look back at the vector-valued function we used in our last example when we found the unit tangent vector already. Here we're going to go ahead and find the formula for the principal unit normal vector for this. So if you recall, our t hat that we already worked out in this video was actually negative 3 over root 10 sine of t, comma 1 over root 10, comma 3 over root 10 cosine of t. So we already calculated this earlier in the video. And remember, for our principal unit normal vector here, n hat, what we'll be doing is taking the derivative of our t hat and dividing it by its own length. Now we want to point out here quickly that just because t hat is a unit vector doesn't mean that t hat prime is a unit vector. So this is not guaranteed to be 1 down here for our magnitude of t hat prime. Even though you see a hat here, this is the derivative of t hat. So just be careful with that. So let's go ahead and do our t hat prime. So t hat prime we'll need first. That's going to be the derivative of this. So we'll still have our multiple of negative 3 over root 10 cosine of t now. The derivative of this 1 over root 10 is going to be 0. And here the derivative of 3 over root 10 cosine t will be negative 3 over root 10 sine of t. We've got our t hat prime, we've got this top part here. We'll need the magnitude of that t hat prime to make this a unit vector. So the magnitude of t hat prime here is going to be the square root of all of these things squared. So we'll have the square root of negative 3 over root 10 cosine of t squared, technically plus 0 squared. That's not going to change anything though. Plus negative 3 over root 10 sine of t squared as well. If we give ourselves some more room here, we'll have the square root of, if I square this here, I'll actually get 9 over 10 cosine squared t plus 0, nothing there, plus we'll have 9 over 10 again, this time with sine squared t. And so what we really have is 9 over 10 times the Pythagorean identity again that we had earlier in the video, cosine squared of t plus sine squared of t. So this is really all 9 over 10 times 1. So we'll get the square root of 9 over 10 then for this one. And we know the square root of 9, so let's go ahead and think of this as root 9 over root 10, which is really 3 over root 10. So now to solve our principal unit normal, our n hat, remember that's going to be t hat prime divided by its own magnitude. And so that's going to be this vector here. We have negative 3 over root 10 cosine t, comma 0, comma negative 3 over root 10 sine of t. And all of that is going to be divided by this 3 over root 10, the magnitude of t hat prime. Now I think you can see for each of these non-zero terms, when we divide by this constant, we're going to get rid of those. So we'll actually just get negative cosine of t, comma 0, comma negative sine t. And you can certainly check if you would like to that this is a unit vector. But this is a vector that is normal to the curve. It's our principal unit normal vector. It's a unit vector, and it points in the direction of change of the tangent vector at any point in time. We'll work through one more example now all the way through from start to finish here. This one a little more calculation heavy than the previous one. This will give us a good example of how sometimes when working these, a lot of the calculations need simplifying. Along the way, we're going to find the unit tangent and the principal unit normal vectors for this vector valued function, 2e to the t, comma, e to the t sine t, comma, e to the t cosine of t. So the first thing we're going to do is find our unit tangent vector, t hat. And now remember that is the derivative of our vector valued function divided by its own magnitude. So we'll first need to find our r prime of t. Our r prime of t, this first component, is pretty simple. We're going to have 2e to the t, just as its own derivative. And now we have a product rule for each of these. Now the derivative of e to the t sine t, the derivative of e to the t is itself. We'll leave sine of t alone. Adding to it from the product rule, leaving e to the t alone this time, times the derivative of sine of t, which would give us cosine of t. That's our second component. Our third component, a similar product rule here. The derivative of e to the t is e to the t, leaving cosine of t alone, plus, now if we leave e to the t alone and then take the derivative of cosine of t, that's actually negative sine of t, so I'm going to actually go back and put a minus here. We actually get minus e to the t sine t for that one. So that's our r prime. Now we'll need to figure out what is the magnitude of r prime, and you can see this might be a little bit of work, but we're going to get through it. And I'm going to actually start down here because it's a lot to write. So we'll have the square root of all of these things squared, right? So we'll have 2e to the t squared plus the quantity e to the t sine of t plus e to the t cosine of t, all squared, plus here e to the t cosine t minus e to the t sine of t, all squared as well. And a root over all of that, we'll give ourselves some more room. So that is going to be the square root of, if we square the first one, we'll get 4 e to the t times e to the t is e to the 2t, so just be careful there. Now here we'll have two copies. We'll need to FOIL or distribute them into each other. So we'll have e to the t sine t times itself, which would give us e to the 2t sine squared t. If we distribute two of these into each other, we're going to get this sine t term times a cosine t term over here, and a cosine t term times a sine t in the first one. We're actually going to get plus 2 e to the 2t sine of t cosine t terms. Plus, when we distribute e to the t cosine t and multiply by itself, we would get e to the 2t cosine squared t. So we've done these two. If we distribute this last one here, e to the t cosine t times itself will give us e to the 2t cosine squared t. Since this is negative, we're actually going to get 2 times both of these, but it's going to be minus. So we'll get minus 2 e to the 2t sine t cosine t. And then here, negative times a negative will give us plus e to the 2t sine squared t. Okay, so all of this big mess here under a square root. We'll go ahead and notice maybe what happens here. This plus 2e to the 2t sine t cosine t and this minus negative term over here, those will reduce to 0. So we'll get the square root of 4e to the 2t, and then I have an e to the 2t sine squared t and another one here. So I actually have plus 2 e to the 2t sine squared t's. And then we also have 2 of this cosine term as well, so plus 2e to the 2t cosine squared t. under the square root. Now we've got some simplifying still to do here. Notice we have a sine squared t and a cosine squared t. So let's go ahead and think of this as 4e to the 2t plus 2e to the 2t factored out from sine squared t plus cosine squared t terms. So if we put a root over all of that, now we know that this is 1 here because of Pythagorean identity. So we really get the square root of 6e to the 2t, and we can split that up as the square root of 6, and then e to the 2t, the square root of that would actually be e to the t. So we get root 6 times e to the t for our magnitude of r prime. Now we'll have to take our r prime and divide it by its magnitude to get our t hat, our unit tangent. So let's do that. All right, so if we scroll down here, our t hat is actually going to be 2e to the t. We had e to the t sine t plus e to the t cosine t. For our second component, our third component was e to the t cosine t minus e to the t sine t. And all of that is going to be divided by root 6 e to the t. So you can sort of see what happens here. Everything has e to the t in it up top, so we'll get rid of that. We'll reduce all of the e to the t terms here. So it helps us a bit in simplifying. We certainly want to do that. For our first term, you'll notice we just get 2 over root 6. And then here we actually get 1 over root 6 times sine of t plus cosine of t for our second component. For our third component, we get 1 over root 6 times cosine of t minus sine of t. Okay, so that is our unit tangent vector. We have one of them. Now we also need the principal unit normal vector. And remember, our principal unit normal vector, our n hat, that's going to be our t hat prime divided by its own magnitude. Okay, so let's go ahead and figure out some things here. So we'll need t hat prime. So let's go ahead and do that. T hat prime. This may be not so bad with the exponentials gone now. The derivative of this first term constant is going to be 0. And then the derivative of this will keep our 1 over root 6. The derivative of sine t is going to give us cosine of t, and the derivative of cosine of t will get minus sine t there. That's our second component. We'll keep our 1 over root 6 for our last component, times the quantity here. Now we'll get actually negative sine of t, and we'll get minus cosine of t. Okay, so that is our t hat prime. Not too bad. And now we just need the magnitude of this, right? So we need, I'm going to give myself a little bit more room here, the magnitude of t hat prime. That's going to be the square root of 0 squared, so we won't write that in there. 1 over root 6, if I square that, that's 1/6. And then if we think of 2 copies of cosine t minus sine t, and we multiply them into each other, that's going to give us cosine squared t. We'll actually get minus 2 sine t cosine t. And then negative sine t times negative sine t will get plus sine squared t. Plus we have our 1 over root 6 squared again, so that'll be 1 over 6. And then here we'll end up with a sine squared t in the front, plus 2 sine t cosine t, plus cosine squared t when we distribute this last thing. Everything in there is under a root. And now let's kind of look at what we have here and notice that, I mean, everything has a 1/6 outside of it, so I think it's okay to say that this minus 2 sine t cosine t and plus 2 sine t cosine t are going to go away here. And we're going to end up with, when we distribute the 1/6, so we have 1/6 cosine squared t and sine squared t. We'll have a 1/6 sine squared t and cosine squared t over here as well. So if you think about the like terms, the cosine squared t terms, we have 1/6 plus 1/6. That's actually going to give us 2/6, also known as 1/3 cosine squared t We'll have the same thing with the sine terms that both have a 1/6 in front of them. 2/6 will make 1/3 sine squared t. And we have another situation here in the end where we really have 1/3 times a Pythagorean identity here, right? So if you want to factor out the 1/3 and see it for certain, you can do that, but we're just going to call this 1/3 times 1 here. So we have the square root of 1/3, also known as, if you prefer, 1 over the square root of 3. That is our magnitude of t hat prime. And so now to figure out our principal unit normal vector, so our n hat is actually going to be this unit tangent that we got. So that's going to be 0, 1 over root 6, cosine of t minus sine of t. And actually here, let's go ahead and bump out a negative. So let me call this negative 1 over root 6. Then we can make it sine of t plus cosine of t. That might look nicer. So we'll have that divided by this magnitude, 1 over root 3. So obviously 0 isn't going to be affected. That will stay 0. And if we think about 1 over 6 divided by 1 over root 3, that's really what we need to do. Let's do that over the margin here. So we have 1 over root 6 divided by 1 over root 3. That's the same as multiplying by the reciprocal like that instead. So that gives us root 3 over root 6. Right, so what that actually gives us then is root of 3 over 6, also known as square root of a half, also known as 1 over root 2. So these numbers here are actually going to become 1 over root 2 once we divide by this 1 over root 3. So we'll actually get our n hat as 0, 1 over root 2 times our quantity cosine of t minus sine of t. Here we'll get negative 1 over root 2. This one will be sine t plus cosine of t. All right, everyone, long example, but hopefully that helps you seeing some examples of these unit tangent and principal unit normal vectors worked out. Thanks for watching. We'll see you in the next video.